students, welcome to the beautiful world of mathematics. In our last class, we discussed about beauty of nature and the secret behind that. Every beautiful thing will have a mathematical secret behind them. Do you remember the beauty of sunflower which we have discussed there? See how the petals of sunflower are arranged. Yes, there is a mathematical secret behind that. What is that number secret? Have you heard Fibonacci sequence? 1, 1, 2, 3, 5, and so on. The petals of sunflower are arranged in this order. How this sequence is formed? See, first number is 1. Again, next one is also 1. The sum of 1 and 1 is our next term, 2. When you add 2 with 1, we get next term, which is 3. See then, the sum of 3 and the previous number 2 will become 5. So this is the number secret. Okay, that means every beautiful things in our nature will have some kinds of mathematical secret. So, can we make such sequences or collections of numbers from different situations? Let us try to make such a sequence. Have you played with matchsticks in your lower classes? I think you will have made some patterns by using matchsticks in your lower classes. Okay. See this? Please try to draw this pattern in your notebook. Yes. See the first one? How many matchsticks are drawn for getting first figure? 3, no? Then how many more are needed for getting next? Good. 2 more. That means 5. What about next figure? Again 2 are needed. That means from these patterns of figures, we can make a pattern of numbers. That means number of sticks used for getting each triangle, each figure. 3, 5, 7, and so on. You can make the next figure, or without making the next figure, you can understand what will be the number of sticks used for getting that. Okay, that means the mathematical secret behind this picture pattern is clear to you. Let us come to our textbook now. See our textbook. Now come to the first page of your textbook. Okay, there you can see arrangements of some squares there. Look now. Let us try to make some collections of numbers from this figure. Are you ready? Okay, let us start. First you write the length of each square. It is clearly written there, no? Yes, write in order. 1 centimeter for first figure. So 1, 2, 3, 4, etc. That means counting numbers or natural numbers. Okay. Let us think about the perimeter of each square. Don't you know what is perimeter? Suppose you are in a room. Then if you try to walk around the room, then when you come back to your earlier position, you will have passed through the perimeter of that room. That means for the first square, the perimeter will be, let us start from here, 1, 1, 1, again 1. How many ones are used? 4, 1. That means 4 into 1, 4. What will be in the case of next figure? Their one length is 2 centimeter. So 2, 2, 2, 2. 4 2s makes 8. Then can you guess what will be next? Yes. 4 3s are added. So 4 into 3, 12. So we get another collection of numbers from this figure. What is that? Yes. 4, 8, 12 and so on. Can you write area of these squares now? What is area? We know area of a rectangle is length into breadth. In the case of a square, all the sides are equal. So side square, side into side. Okay. What about the first square? Its length is 1 centimeter. So 1 into 1. That means 1 square. 1 itself. What will be in the next figure? Length is 2 there. So 2 into 2. 2 square is 4. Then in next square it will be 3 square. Next will be 4 square. 5 square. In this way. Okay, it's very simple, no? So we get another sequence. Another collection of numbers. So we have made different kinds of number patterns from these picture patterns. So these picture sequences or these figures will have some number secret behind that. We can make different kinds of sequences from first one pattern itself. So we have made first 3, 5, 7. Next, counting numbers. First one is 1. Second one is 2. Third one is 3. In this way. What about the next one? Perimeter. What was the perimeter of first one? 4. So the first term is 4. What was the second term? 4 into 2, 8. Third term, fourth term, fifth term, in this way. In the case of area, the first term is 1 square, 1. Next term is, or second term is 2 square, 4. Third term is 3 square, 9. That means these all are number sequences. What is the meaning of a number sequence? The collection of numbers which we can say first term, second term, third term and so on. By keeping a particular condition is called number sequence. So we have made this all sequences by following some conditions, isn't it? So all these sequences are made upon some kinds of conditions. Do you think every sequences are increasing? See one more picture here. Here is a square. Length of one side is 1 centimeter. See the next figure. Its one side is halved. So its length of one side, the shaded square will have one side half centimeter. What about the next figure? Again same length. The length is divided into 4 parts. So the length of the third shaded square will be 1 by 4. So this is also a number sequence. So remember, number sequences may be increasing, decreasing, or in many other ways. Now the concept of number sequence is clear. Okay. Now let us try to predict the particular term of a sequence. Let us try to do so by using some sequences which we have already discussed. Let us discuss the counting numbers. It is a very simple sequence. The first term is 1, second term is 2, third term is 3, and so on. What will be 10th term? 10. 50th term? 50. Okay. 100th term? Say. 100. Very good. Now my question is, what will be nth term? Yes. Nth term means, in mathematics, we will try to generalize some mathematical ideas. Mathematics is a subject which tries to generalize by using some letters, some simple equations. That's why, can you say the nth term of this sequence? It is simply n. Okay. Let us think about next one. The sequence was 4. First one is 4. How 4 is made? We made the sequence by taking perimeter of the square. Squares, no? Here. So 1, 1, 1. How many ones? 4 ones. Next one is, how many twos? 4 twos. 4 into 2. It was 8. In next term we have calculated 4 into 3. That is 12. Now the question comes now. What will be 10th term? 4 into 1 was first term. 4 into 2 was second term. 4 into 3 was the third term. Then what will be 10th term? Very good. 4 into 10. What about 50th term? That means there will be a square which have a side 50. We are not going to do such a square. A mathematician will not do every experiments. By using their logical sense, usually mathematicians will think what will be there. As we have told in first class, what will be beyond that? Mathematics put forward some questions. What will be beyond that? So here also comes that question. What will be 50th term here? 50, 50, 50, 50. 4 into 50. What will be 100th term? Yes, very good. 4 into 100. Then can you say what will be the nth term n into n plus n plus n plus n. How many n's are there? 4 into n. So 4n. That is the mathematical secret of this number sequence. Think about the area of the squares. First one we have 1 square, second one's area is 2 square, third one's area is 3 square. Then in this way, what will be the area of 10th square? 10 square. 50th square, 50 into 50 square. What will be the area of the 100th square? Very good. 100 into 100 square. Then arise the question. What will be the nth term? First term is 1 square, second term is 2 square, third term is 3 square, fourth term is 4 square. Nth term will be n square. Very good. So, we have seen the nth term of these sequences. The nth term of a sequence is known as algebraic form of that sequence or general form of a sequence. That means for these all sequences we can make a general form by understanding the particular condition used to make the sequence. Do you think every sequence will have such a algebraic form or nth term? Can you say the nth term of every sequence? We think so, no? Let us take the example of prime numbers. Haven't you heard about prime numbers? Which are them? What is the meaning of prime number? Can you say a prime number? Is 1 a prime number? A prime number will have 2 and only 2 factors. 1 will have only 1 factor. 1 square is 1. Think about 2. 1 into 2 is 2. So the factors are 1 and 2. What about 3? 1 into 3 is 3, no? So it is also a prime number. What about 4? 4 into 1 is 4 and 2 into 2 is also 4. Is it a prime number? No. Think about 5. Yes. So which are the prime numbers? 2, 3, 5. Next one. Not 6. 2 into 3 is 6, no? 7. What will be next? Many students will think next will be 9. Is it so? No. 9 means 1 into 9 and 3 into 3. So we have more than 2 factors. 9 is not prime. 10 is not prime. But 11 is a prime number. So the prime numbers can be written as 2, 3, 5, 7, next. Not 8, not 9, not 10, but next one is 11. Can you make a general form or algebraic form or nth term of such a sequence? No, we cannot. So we have to understand some sequence will have no nth term or algebraic form. Okay. Now we have learnt nth term of a sequence. We should understand nth term of a sequence is the secret of that sequence. We have written nth term from many sequences, no? Can we make sequence if the nth term is given? If it is the secret, we can write its reverse also, no? Think about the nth term of counting numbers. What's it? N. If we take 1 as n, we get 1. If n is 2, then we get 2, 3, 4 in this way. So we can make the sequence again. What about the nth term of and the next sequence? What was it? That's 4n. Can we make the sequence? Yes. 4 into 1, 4. Yes. Instead of n, we have taken 1. If we take n is equal to 2, 4 into 2, 8. 4 into 3, 4 into 3, 12. So again we have got the sequence. Okay. Think about next one. N square. N square was the nth term or algebraic form of the next sequence. N square. Okay. If n is equal to 1, what will get? 1 square, 1. Area of the first square. Do you remember? If n is 2, we get 2 square means 4. 4 was the area of our second square, which is one side was 2. Then next one, n is equal to 3. N square is 3 square, 9. So we got 1 square, 2 square, 3 square, 4 square in this way. Again we have got the sequence. From this we understand that if we get some sequences, in most of the cases, we can write the nth term algebraic form or general form. But remember, there are many other conditions in which we cannot make the nth term. And when we get nth term, we can write the sequence also. So we have studied now about patterns, sequences of figures, number sequences, and algebraic form or general form or nth term of a sequence. Nth term is the, as I told you, nth term is the secret behind the sequence. That is why nth term is very important in the case of a sequence. So, let us try to understand more interesting features of sequences and more interesting secrets of beauty and the secret behind beauty of our nature. See you in next class. Thank you.